This is part 2 of lesson 2.2, and in this video we'll be going over an example that demonstrates moments. Let's take a look at this example of a windlass. Suppose that 5 people are using a windlass to wind in the anchor of a ship. As the windlass turns on its vertical axis at Q, it acts like a winch, pulling on the rope or chain to which the anchor is attached. The force produced by each person is shown. Each person is identified by a letter A through E, and they're each exerting some force at different locations on the windlass. For reference, the grid lines are spaced 0.5 meters apart, so each unit is 0.5 meters. And I'll write down our positive sign conventions to remind us that counterclockwise is positive. There are 4 questions that follow this example, and I'd suggest that you pause at each one to try to answer it for yourself before I walk through the solution. The first question asks, what moment does each person produce about the center of the windlass? From the first part of this lesson, we came to a conclusion that a moment is the product of the force and the perpendicular distance to the point of rotation. Our point of rotation in this question is Q, so I'll be multiplying the force exerted by each person by their distance to Q to solve for the moments. I'll go in alphabetical order and solve the moment produced by each person. Person A is exerting a force of 50 newtons in the counterclockwise direction, 2 units from Q, which gives us a moment of 50 Newton meters. Person B is exerting a force of 35 newtons in the counterclockwise direction, 4 units from Q, which gives us a moment of 70 Newton meters. Person C is exerting a force of 20 newtons in the clockwise direction, 3 units from Q, which gives us a moment of negative 30 Newton meters. Person D is exerting a force of 75 newtons in the counterclockwise direction, 2 units from Q, which gives us a moment of 75 Newton meters. And finally, person E is exerting a force of 15 newtons in the counterclockwise direction, 4 units from Q, which gives us a moment of 30 Newton meters. Now the second question wants us to calculate the total moment produced, which is essentially just the sum of moments produced by each person. The total moment produced will be 50 Newton meters plus 70 Newton meters minus 30 Newton meters plus 75 Newton meters plus 30 Newton meters. We're adding all the values except for the 30 Newton meters produced by person C because they act in the positive counterclockwise direction, whereas the 30 Newton meters produced by person C is being subtracted because it's acting in the negative clockwise direction. From this, we get a value of positive 195 Newton meters, which tells us that it will be acting in the counterclockwise direction. Question 3a asks, what changes could the team make to increase the total amount of the moment produced? List at least 3 different kinds of improvements. There are various changes that can be made to this diagram, but I'll just show one variation of these changes, which includes moving person A 1 meter further from Q, having person C push in the counterclockwise direction, and moving person D another 0.5 meters away from Q. Once again, there are many different solutions to this question, but I'm just showing one possible arrangement. Part B of question 3 asks us to draw the improved arrangement and wants us to calculate the total moment they now produce. I'll redraw the forces exerted by each person according to the adjustments I wrote in the last slide. So person A is now 2 meters from Q, person C is pushing in the counterclockwise direction, and person D is now 1.5 meters from Q. To calculate the total moment, we'll take the sum of moments about Q. Our equation will be the sum of m about Q equals 50 newtons from person A, which you're adding because it will act in the counterclockwise direction, times its normal distance to Q of 2 meters, plus 35 newtons from B, which we're again adding because it will act in the positive counterclockwise direction, times its normal distance to Q of 2 meters, plus 20 newtons from C, which is also being added because it will act in the counterclockwise direction, times its normal distance to Q of 1.5 meters, plus 75 newtons from D, which you're adding because it will act in the counterclockwise direction, times its normal distance to Q of 1.5 meters, plus 15 newtons from E, which we're also adding because it will act in the counterclockwise direction, times its normal distance to Q of 2 meters. This will give us a total moment of positive 342.5 Newton meters, which will be acting in the counterclockwise direction since it's positive. Question 4 is a bit different. Suppose one of the windlass arms is at a skewed angle. How would you do your moment calculations? First of all, we need to establish a new coordinate system, so these will be our new positive sign conventions. Since the windlass arm at which person A is pushing is skewed at 45 degrees, that means that person A is no longer pushing in a perpendicular direction with respect to the arm. So the distance between the force and point Q is no longer 1 meter. To get this distance, we can use our special triangles. We know this distance here is 1 meter and the angle is 45 degrees, so we can easily get the hypotenuse, which will be square root of 2. As for the force, we must break it up into its x and y components because we want the force that's perpendicular to the distance from Q. We can ignore the x component, Fx, because if you extend the line of its force, you can see that it will pass through point Q, meaning that it does not affect the moment about Q. Using trig, we can get the forces Fy, which will be F times sine of 45 degrees. So 50 newtons times sine of 45 degrees, which gives us a value of 35.36 newtons. As before, we'll calculate the total moments about Q. So the sum of M about Q equals 35.36 newtons from the y component of person A, which we're adding because it will act in the counterclockwise direction, times its normal distance to Q of root 2 meters, plus 35 newtons from B, which we're again adding because it will act in the positive counterclockwise direction, times its normal distance to Q of 2 meters, minus 20 newtons from C, which are subtracting because it will act in the clockwise direction, times its normal distance to Q of 1.5 meters, plus 75 newtons from D, which are adding because it will act in the counterclockwise direction, times its normal distance to Q of 1 meter, plus 15 newtons from E, which are also adding because it will act in the counterclockwise direction, times its normal distance to Q of 2 meters. This will give us a total moment of positive 170 Newton meters, which will be acting in the counterclockwise direction since it's positive. To wrap up the example we just went through, I have a few fill-in-the-blanks that I'd like you to try filling out on your own. So, as seen in the previous example, when a force is not perpendicular to the arm of rotation, we must use trig components to calculate the moment. The best way to calculate the moment of the force acting at an angle is using the equation m equals F times sine theta times d, where m is the moment about the arm, F is the applied force, theta is the angle between the force and the arm of rotation, and d is the perpendicular distance between the force and the point of rotation.